Hi guys, welcome to Deriva's Code Tech, and today we are going to see the problem in Geek for Geek is integral points inside triangle. In this problem, they said that they have given three non-coordinate points and their coordinates are in the form of x comma y. You can see here p1 comma p2, q1 comma q2, and r1 comma r2, which are present in an xy plane. Okay. And what we need to return is that we need to return the lattice points which are strictly formed by using these three coordinates. Okay. What does it mean is that using these three coordinates, they have formed an triangle. And inside this triangle, we have certain lattice points. And we need to return that lattice point as our output. That's it. Okay. How we can able to find out is that by using Pick's theorem. In Pick's theorem, they have stated that any polygon which have at least three sides of straight lines can be formed by using n coordinate points like p1, p2, q1, q2, and r1, r2 can be find out their area by using this Pick's theorem. That's what this Pick's theorem is stating about. Okay. This in this Pick's theorem, they have been founded on 1899 by George Alexander Pick. He stated that not only you can able to find out the integral points or area by only using Fixed theorem only is not applicable for triangle. It's applicable for all the polygons. Either it can be rectangle or square or parallelogram or anything, but except circle. Reason here is circle doesn't have any straight lines. And most importantly, to use this fixed theorem, and any shape should have at least three straight lines. And we can able to make sure that triangle have three straight lines. And so that case we are using fixed theorem in our concept. Okay. In this fixed theorem, we need to we need to focus on two main parts. The first one is we are going to find out the lateral points which are present inside this polygon, present inside the triangle. And after that, we need to find out the points which are in our edge sides. That's what we called as AC, AB, and BC. And these are called as edge boundary lines. And in these edge boundary lines, we need to calculate the number of points which are present on there also. That's very important point. Okay. After that, what I'm going to do here is you can see here fixed theorems A equal to I plus B by 2 minus 1. A is nothing but area of the polygon. Okay, I said that this polygon this particular theorem is not only applicable for triangle, it is also applicable for all the shapes. So that's why they have mentioned it as polygon. Okay, now A is equal to area of polygon and B is equal to number of integral points on edges of polygon. We are also going to found the integral points which are in the edges of the polygon. You can see A is an edge, A, B, and C are the edges of formed triangle. We are also going to find out the integral points which are formed through those edges. After that, I is equal to number of integral points inside the polygon. This is what we are going to find out. Okay, this is what our necessary part is about. They said that return number of integral points. So this is what we are going to return in our program. So for calculating I, I'm going to keep the I as constant in my left hand side and rest of the things will move on to the right hand side and will be like this 2a minus b plus 2 by 2 or a minus b by 2 plus 1. So just they are divided by 2. So when you divide it by 2, 2 will get cancelled and b by 2 will be as such as and then plus 2 by 2 will be 1. So that's I have been written as a minus b by 2 plus 1. That's it. Okay. After this, I got the integral formula. Okay, no problem. What will be my area formula? We know the area of triangle is half of base into height. But here, most importantly, we are not going to use base into height. They are in parts of coordinate points A, B, and C. For these coordinate points, we need to use shoelace formula. What does it mean? Shoelace formula. Okay. In this formula, you have been maybe you have studied in your 11th or 12th. I don't know, but I remember somewhere I have read this formula. So in this formula, you can able to form the coordinates by using x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. When you have three coordinates x1, x2, and x3, in that case, you need to use like this. That's what the Shoelace formula is trying to say upon. After this, we know the area and we know the integral formula. Then what does it be? B is nothing but the boundary line. So we are going to follow the boundary line points of the polygon. So let me move on to this. So number of integral points on edges of your triangle. Edges or the boundary lines all are same. The edges. In the edges parts, how you are going to find the integral points on that. So first of all, only consider this first part. Okay. You can see my cursor. Only focus on this part. Okay. Now you are formed a triangle by using three coordinates A, B, and C. After forming the triangle by these three coordinates, you need to find out the boundary line. So just like that, calculating the integral part is not enough. Okay, to get this integral part, you need to separate from the boundary line also. So that's the reason we are calculating the boundary line in our problem. Okay, when you find out the boundary line, you can just like that you can apply on our formula and just you can get the integral lattice points. And most importantly, there are three most test cases which are going to fall in this boundary line. The first one is when vertex 1 and vertices 2 are parallel to x-axis. In that case, what I'm going to do here is I'm going to just going to separate the y points by 1. Okay. What I'm going to do here is, for example, let me take this example. You can see 2 comma 3 and 5 comma 3, and this is parallel to x-axis. When this is parallel to x-axis, what I'm going to do here is I'm going to subtract the y coordinates of one point and y coordinate plus another point. I'm going to subtract it and I'm going to give out my answer in terms of positive. So for that case, I have used ABS. So when you separate it, you will get the value as 2. See, I have used 5 minus 2. Actually, this is not x-axis. We need to use y-axis. See, 2 comma 3 and 5 comma 3. Here you need to write ABS of 3 minus 3 minus 1. I have mistakenly written as 5 minus 2. Okay, sorry. Sorry for that. And okay, this is one condition. Second condition, when y-axis is parallel to when v1 and v2 parallel to y-axis, when these two coordinates are parallel to y-axis, in that case what you need to do is you need to do abs of v1 dot x minus v2 dot x. So same here also I did some mistake. Here I need to add minus 5 comma minus 5 minus 1. Okay, I have used minus 2 minus 5, so sorry for that. Okay, this is on two condition. What is the third condition? If my one of the coordinate lies in my origin 0 comma 0, in that case I need to use GCD, greatest common divisor, to find out the particular answer. So for that case I will use GCD of minus 3 comma 0 and minus 3 and then 3 comma 0 minus 3 comma 0 comma 3 comma 0 minus 1. Using this GCD part, you can able to find out the particular boundary points. Okay, after this just you apply in your integral formula. I equal to 2a minus b plus 2 by 2, you will get your answer. So that's it, what the problem is going to focus on. Okay, let me see in our coding part in our next section. Bye.